Okay, so we are going to be looking at the rest of the study guide that we didn't get to in class today. So, the health of the bear population in Yellowstone National Park is monitored by periodic measurements taken from anesthetized bears. A sample of 55 bears has a mean weight of 182.9 pounds. Assuming that the population standard deviation is known as 121.8 pounds, find a 92% confidence interval estimate of the mean of the population of all bear weights. So what we know here is that a sample of 54, so N is 54, has a mean of 182.9. And then assuming that the population standard deviation, it says population standard deviation is 121.8. Find a 92% confidence interval estimate of the mean. So we need our Z. What we're going to be finding is our confidence interval. So we need to first find our margin of error. E stands for margin of error. And to do that, we have to find our Z. We know it's Z because it's population standard deviation. And we see this is a 92% confidence interval, meaning we have 0.08, which would be 0.04 on either side. So we need to find our critical value. We can go in here, and it's normal dist, and we know that the mean is 0, standard deviation is 1. Hold on. And then inverse CDF is 0.0, what do we have, 4? So my Z-score is 1.75. So for my margin of error, we're using the formula the Z-score times the standard deviation over the square root of N. We found that our Z-score is 1.75. Our standard deviation, our population standard deviation, over the square root of 54. Now you calculate. When you calculate that, you can put in a calculator. We get 29. So what that means is to find our confidence interval, we have to say the mean minus the margin of error and the mean plus the margin of error. So we have 182.9 minus 29, and then 182.9 plus 29. And we find that our mean is between 154 and 212 for a 92% confidence level. All right, looking at number 12. In a study of perception, 80 men are tested and 7 are found to have red-green color blindness. Construct a 97% confidence interval estimate of all men with color blindness. Okay, so in this one, we don't know any of the standard deviations. We don't know. It has not told us the mean. So this one's going to be a population proportion because we do not know either of these. We do not know that, and we do not know the mean. We don't know any of that. So it tells me what I do know is that we're going to have to first find our margin of error. So our formula for the margin of error is to find the z-score and multiply that by the square root of p, not p, divided by n. So there are 80 men are tested, so our n is 80. 7 are found to have red-green color blindness, so that is 7 out of 80. So then how many people do not have the red-green color blind? That would be 73 over 80. So now we just need to find our z-score of 0.015. And we do that because there's a 97% confidence interval. And so there's 3% to make up. So this would be 1.5%, which is 0.015, 0.015. So you can go in to Desmos to find your z-score. 0.015 is a 2.17. So that is my critical value. My critical value is 2.17. And so for my p, that is 7 divided by 80 times 73 over 80 divided by 80. And all of that's under the square root. So when you type that in, you find out that your margin of error is 0.069. So to find our confidence interval, we would say P minus the margin of error is between, the P is between the difference and the sum. So we would have 7 over 80 minus 0.069 and then 7 over 80 plus 0.069. In doing the math, 7 over 80 minus 0.069 is 0.0185. Then the sum is 0.156. The big thing here is to be able to read the problem and know which formulas you're using. So looking at 13, in a survey of 2,096 U.S. adults, 1,740 think football teams of all levels should require players who suffer head injury to take a set amount of time off from playing to recover. Construct a 94% confidence interval for the population proportion. So 94% confidence interval tells me that we have 3% and 3%. When I'm reading it, it tells me here for a population proportion. So we're going to do this like we did number 12. So E equals, we have to find our z-score. So over here, I'm trying to find my z of 0.03. $1.88. So that is 1.88 times. So I know it tells me in a survey, this is my N. Now, it says 1,740 think that they should take time off. So how many do not think that? So you would say 2,096 minus the 1,740, which is 356. So you would have 1, 7. Okay, so now you do the math. 188 times the square root of all this. You can put that in a calculator, type it into Desmos. Okay, and we get, for a margin of error, 0.015. So our P, we do our P minus margin of error, and then the probability plus the margin of error. Okay. And we find our confidence interval. So that means the probability should be between 81.5% and 84.5%. 94% confidence interval. That's the percent that do think. So in our sample, we found that the 1,740 over 2096, which that was, let's see what that was. So like our sample was 83%. That's what our sample found. But we're saying anything between 81.5% and 84.5% would fall in the 94% confidence interval. In a random sample of 40 patients, so as I'm reading, I like to think, what do these numbers represent? So N is 40, that's the sample size. The mean waiting time was 20 minutes, and the standard deviation was 7.5. Nowhere in here did it talk about population standard deviation. So we are dealing with, this is S. It's the sample standard deviation. So we're going to be working with t values. So to find my t, I do t dist. We need our degrees of freedom. So that's n minus 1. So that's 39 dot inverse CDF 0.01. So you would do that and find your t. So our t of 0.01 is 2.43. So I need to use my margin of error formula. And that would be my t-value times the sample standard deviation, which is 7.5, divided by the square root of n, which was 40. Doing so, I find my margin of error is 2.88. So we will say the mean minus the margin of error is going to give me, we're finding the mean plus the margin of error to give M a good population mean interval. Okay, so this would be, it was 20, so 20 minus 2.88 gives me 17.1, and 20 plus 2.88 is 22.9. So the mean is between 17 and 1/10 and 22 and 9/10 minutes with a 98% confidence interval. And then lastly, in a random sample of 15 cereal boxes, the mean weight, so if 15 is in, the mean weight is 18 and 89/100ths. Assume the weight of the cereal boxes are normally distributed and the population standard deviation is 0.05. Construct a 90% confidence interval. So we know this is population, so we're finding our z. And when we find our z, we find that is 1.64. For our confidence interval, we're using the z-score times the population standard deviation divided by the square root of n. We found our critical value is 1.64 times 0.05 divided by the square root of 15. And when we do the math, we find our margin of error is 0.02. So we will do our mean minus the margin of error and our mean plus the margin of error. So the mean was 11.89 minus 0.02, and then 11.89 plus 0.02. So 11.87 and 11.91. So remember, our test is next class. I hope this helps. Reach out if you have any questions at all.